Hello and welcome to Thrifty Tool Shed review number 1. I'm Phil with Thrifty Tool Shed. Today we're going to look at the GM328 tester, this component tester that you can buy very cheap, and though it comes with absolutely zero documentation when you buy it, some searches on various websites and some information you can find by searching, it shows similar to the description you see online before you buy it. For example, it lists that it has the Atten 328 microcontroller, the 128 by 64 pixel LCD display with a backlight. It's got a really nice backlight on the display. I like that. It talks about the 8 megahertz crystal and the current consumption of 20 milliamps on the battery, and it takes a standard 9-volt battery. It mentions that as well. But on various sites it mentions the testing of transistors, JFETs, MOSFETs, diodes, SCRs, thyristors, triacs, inductors, and of course capacitors and ESR, which is well sought after with the equivalent series resistance checks. It also shows the V-loss on some larger capacitors. We'll get into those tests momentarily and get some hands-on and maybe show you a little bit about how to use it. There's resources out there. You kind of got to search a lot for it. I thought about putting this together to see if it'll help somebody else just buying one. But just to talk a little bit about the tester, mine came from Amazon at $21.97. That's US dollars, and it's noted as one of their best sellers. It's a top selling item. And it's quite impressive once you learn the capabilities of the device as well as some limitations, as any piece of test gear has. So we'll get right into component testing and get into the menu and look at further capabilities, including adjusting the contrast, which I know on the display has gotten quite a few people. So here we go. Off testing with the GM328 with resistors, and go into maybe inductors and then capacitors. Notice the ZIF socket, pin 1, 2, 3 and 2 repeats, and 1, 2 and 3. It doesn't matter which pin you put it in, as long as if it's a 3-lead device you want to put it in like 1, 2, 3. Just realize that 2 repeats here, but it gives you a lot of different ways to hook up an item, especially if the device only has 2 leads. It's really got a lot of capabilities, and this does help a lot because I can put some leads in here and be easier to test, but this device is so well on resistance and inductance that those leads do actually, you can tell they offer the test. So you could even solder some leads here if you would like to, but again, that does add resistance, as we'll see. The ZIF little socket on 1, 2 and 3 does really well. So let's get into testing. Also, I did mount mine on a piece of Romark. It does come as just the board. It's not mounted on anything. You can use Lexan or polycarbonate or something of that nature. I just happened to have a piece of Romark material that was left over from engraving, and it worked well. Just mounted it on there. And I just have it in this base just so you can see it well on the camera. I think I'm going to start off with an inductor. I didn't have many inductors, so if I can get this to focus here. This is a variable inductor that came off a board years ago. You can see it's soldered together. There's only 2 pins that actually can test on this. I'm going to put it in here. It's going to go across 1 and 3 and hit test. And it shows up as an inductor. It shows 0.2 ohms and inductance of 0.06 millihenry. And I don't have but one inductor, but what I can do is I can adjust this one. Taking the iron core all the way in, and once again testing. we'll see that it's still 0.2 ohm. Now it is 0.14 millihenry. I've had no trouble measuring inductors except for the only other inductor I had was a very large power inductor, and it actually read as a resistance because it was just such a big coil of wire that it actually, the battery just couldn't actually test it properly. We're going to start off with a very low. This is a 0.22. I don't know if you can see the bands on that. You know your resistor color code, red, red, silver, gold. This is a 0.22 ohm resistor. Across 1 and 3, and it's showing 0.25 ohms within tolerance. I have a 10 ohm power resistor. Also across 1 and 3, 10.1 ohms dead on. I have a 220k ohm where the silver is 10%. Across 1 and 3, 236.4k. And then on the high side of things, I have a 5600k or a 5.6 meg ohm resistor with a 10%. See the silver band is 10%. I should turn it over this way. Sorry. With the silver band is 10%. And it's showing 6604K. So this reads just a little out of that 10%, but it is a very high value resistor. I have a 12,000 power resistor. So 12K, and it reached 12.22 k-ohms. Another thing that's kind of neat about this, I realized with the 3 pins, I have a little board mount pot, and you can actually put this on pins 1, 2, and 3. And hit test, and it will show this as a double resistor, and it splits the reading, so you can tell I have tried to put this real close to the center. I'm going to adjust it all the way counterclockwise and read again. And you know, by the way, we can also tell this is a 5K pot really quick too, just by when I had it in the center or anywhere, as long as you add it together. But we see here 0.19 and 5210, so it's a good way to check out a pot, or center one up before you put it in a circuit if it's important to you. Those are very straightforward and easy. Next we'll get into capacitor testing. Now, one thing I want to say about capacitors: always make sure they're discharged. I mean, a high voltage capacitor can't hurt you, but it can definitely hurt the electronics even with a small charge on it. So if it's a small enough capacitor, just short the leads together. But of course, you want to use a resistor. If it's a big enough capacitor and you're not sure if it's discharged, use a similar resistor like I had earlier, a power resistor. Put it across there. Make sure it's dead. I have already done all these, but make sure you do that on every test. Let's start off with a 560 microfarad, 200 volt rated electrolytic capacitor. Across 1 and 3, no problems. Can you see that? Yeah. Test. And we see a reading of 523.3 microfarad. It gives us an ESR of 0.09 ohms and a voltage loss of 0.7%. If I can find this sheet. Let's do that one more time. .09 ohms on your ESR. If we look, verify again, we have a 560 microfarad at 200, which is somewhere in this range right here. This is the only chart that I have, but if you'll see right here, we are at 0.13. So we are below that, and the ESR shows good on this typical ESR chart. I also have a 2200 microfarad rated at 10 volts. Test it. And we show 2233 microfarad with 0.08 ohms. And if we look here, we should be, can you see that? We should be right here at 0.09 or below, so we're good. .12 mylar dip capacitor. And 127.6 nanofarad. It's dead on. Here I have a mica. This one actually I know checks good. And I know that the coloring on this is a little harder to see, so on camera it may be even more difficult. So we'll just test this one, then I'll show you the color chart on another one. This should be 180 picofarad, and it's showing 185 picofarad. And it's not a large enough capacitor to actually show ESR. See if you can get that in here. You see how it shows, you read first, second, this is the type, then you got first digit, second digit, I'm sorry, that's tolerance, this is the multiplier. So if I hold this like this, we see that we have, you can see it on here. We have violet, 7, and green, which is 5. And then the multiplier is black, so it's going to be 1. I have a small MP0, which is rated at 50 picofarad. Well, it's really 56 at 10%. 1 and 3. 54 picofarad. I had some others here, but we're going to move along and get right into testing transistors. I have a 2SK 1045 that I took out of a board that was known to be good, but it does have some age on it. Got it in 1, 2, 3. And we'll see here that it is a N-channel enhanced MOSFET. It shows us 1, 2, and 3 as gate, drain, and source. It also shows the diode around the drain and source, and it shows the forward voltage of that diode. It also gives us the capacitance of the junction, and it also gives us the let's test it again. And it also gives us the transitional voltage of 3.2 volts. And actually I didn't have the data sheet on that one, but I did pull up what it was. And it is a MOSFET N-channel enhanced. And it shows a little more data here. But so that one I was pleased it checked well. I don't know if you can see that or not, but it is a EGC or ECG 5614. And we'll see here, this is the first, you can see that. This is the first item that I had actually checked that did not show correctly. It is a triac. I know it's a triac. I have the data sheet for it. It's just the right package. And this is, of course, a triac. All it shows is a resistance across 1 and 3. So I have some other triacs as well, and they show the same thing or something similar. Next, we have a C1212. So what is this thing? Well, it shows us an NPN with HFE or gain of 122, and it shows 1, 2, 3 as emitter, collector, and base. And it also shows the currents, and we'll get into that in just a minute. But as we can see from this sheet, that is exactly the right pinout, and it is absolutely an NPN. And the gain should be between 100 and 200, so everything checked well with that test. And that's actually the diagram for it. And that's how it shows. So, very useful little device. Next, I have a C3953. We'll see here that it is a NPN. It shows emitter collector base, which is correct. And it should have a gain of 60 to 120, and it's well within that. Next we have a 2N3904, very typical little transistor. Put it in there, test it, and it shows that it is a NPN with 162, and it shows no currents, so we should be good. Just verifies that the pinout is showing correctly. It is correctly identified. just to talk for just a few minutes about the transistor testing. It shows the HFE for the gain, and I believe some versions of this tester show it as B or beta, but I believe it'll be in the same spot depending on what version you have. It does show the collector cutoff current and the flow from the collector to the collector to emitter with the base open rather. And you want both of those to be as close to zero as possible if the transistor is working properly. It also shows the forward junction voltage. I'm gonna go back to the MOSFET for just a minute. Bear with me. Just test it again. Because I meant to show while the screen was up. I think I mentioned the diode across, and it shows the forward voltage of the diode here on the screen, which is nice. But it also shows the transitional voltage, which is the point that the transistor actually starts to conduct or turn on. And it also shows the capacitance of the gate to source. So that might be handy for y'all that might be interested in high frequency or high frequency switching or something of that nature when you're testing one. I think next let's get into some diode testing now. Just a straightforward, it's a little power diode I have from a known good item. Looks like that went across 1 and 2 there. And it shows the direction of it, which is exactly how it should be. It shows the forward voltage of the diode, which is where it should be. It's in range. And so just a typical diode test. I'm going to show a LED, just a red LED, across 1 and 2. You'll see that LED blink as it's being tested, showing us kind of what it's doing to the pins there as it's trying to recognize the device. It shows the diode, it shows the pin out of the diode, and it shows, you'll see that the voltage is a little bit higher being a diode, which that's pretty handy to know. It's at 1.6, I guess, when it first started gating. Here I wanted to test a Zener diode, and this Zener is a 6.5 volt Zener diode. To see how it would test, and it does show as a normal diode, and it shows a typical forward voltage in that direction, but it doesn't show anything about it being a Zener, so I didn't know if it would check a Zener or not. But keep in mind that 6.5 volts is a little bit higher than the 5 volts that I believe this puts out. So I grabbed a 3.3 volt, which is the only one, by the way, I had below 5 volts. And this one rated for 3.3 volts. It's pretty neat. It shows up as a dual diode. It picks it up. It shows it from 1 to 3 and then back from 3 to 1. And it shows that it has, from 1 to 3, it has a forward voltage of 2.2, which must be where it picks up that it's just starting to turn on. And then it shows in the forward direction of 767 millivolts. So pretty sharp that it picked that up, I thought. But the limitation on that is somewhere under 5 volts. It can't pick up, of course, anything over 5. And it may be 4.5 or somewhere in there that it limits that at. I'm not 100% sure. This is a little green diode that I had. A little bit higher current diode, so I wanted to check it just to see If the forward voltage showed higher on it, you'll see it blink as well as it's testing. And sure enough, 1.97. So that might be handy to know. I knew that this was like a 2.1 volt diode when I got it out of the pack, but I don't know that about all my diodes. So alright, with some of the testing shown, now I think a lot of people want to know about the menu items on the device. Okay, now we're set up to go into the menu. I have the Rago DS1102E set up. I just have the resistors in here just as a low resistance way on the lead to go in negative pin 1. The positive is on pin 2 to show the function of a function generator later. But first of all, let's go into the menu, and to do that, just turn it on and let it go through like it's going to do a test. And then you want to press it down 1, 2, 3 and release, and went into the menu selection. And the first thing it goes to in this case is transistor. Let's go alright, back to the transistor. That's where it started at. Sorry, I should have left it there. If you do transistor, what it does is it just takes you, I'm assuming, back to the regular test. If you hold it down, it goes back to where you were at doing a device test or component check. So get that back up. We'll go back into the menu. 1, 2, 3, release. Like I say, it comes back to the transistor, I guess, so you can go straight back into device test. If you click it, one short push, it goes to frequency. Now if you go and hold it just 1, 2, if you go into frequency, it's like a frequency counter. I hadn't figured out how to make that work, or it might not be operational on this version. But I have played with it on several pins and injected a signal. Have not had luck getting it to respond or do I don't really need a frequency counter, but it'd have been cool if it had it. Hold it 1, 2, return back. The next feature is a frequency generator, and we're going to go into that. As you can see already, it comes up on 1,000 kilohertz right into the menu, which is a megahertz, and we're showing, see, can you see that on the screen? We're showing 999.906 kilohertz on the counter, and down here also for frequency we're showing 1 megahertz. A short press, it takes you to 2 megahertz. Now this is where it gets interesting. When you press it again, it actually goes to 1,000 millihertz, which is 1 hertz. So let's break this way back. Yeah, it's somewhere around 100 milliseconds, or maybe even 200 milliseconds on the horizontal. And the counter's just saying less than 5 hertz. But down here on the frequency we are showing, it goes from 996 to right at 1 hertz. So 996 millihertz, that is. Another bump. Oop, I held it too far. Yeah, don't do that. Alright, getting back to 10 hertz where we're at. Take the scale, let's see, to maybe 20 milliseconds. Yeah, that's a pretty nice wave there. And also notice we're showing it almost exactly 5 volt. It's a pretty clean 5 volt square wave. Peak to peak is 5.04 volts. And we can step this through 50, showing 50 hertz on the counter, showing 50 hertz. Kind of got to do a 1, 2 and release. (100 hertz), 250, and then it has a couple other preset as well. 439.9956 hertz, a 441.9890, .0170 hertz, and then we go to 1,000, hertz, 2,500, 5,000 hertz. Let me adjust this out to somewhere around 50 microseconds per division there on the horizontal. And then the next push, it takes to 10 kilohertz, and then 25, going out to 5 microseconds here. So that's the function generator. It actually works quite well. I was pleased to have it. If we hold this for 1, 2, 3, it goes back to the main menu. And the next thing I wanted to show you is the 10-bit pulse width modulation. We go into that. It starts off as a 10%. Can you see that okay? Yeah, I think so. With each press, it goes up by 1%. So one press gets 11%, 12%. You can see these grow. Maybe I should zoom in a little bit more right now. You can see it grow. Go to 20%. I think like a count 1, 2, it goes 10% per push. 1, 2, 40%. Let me go back down to 50 microseconds per division so you can see it a little bit better. 1, 2, 50%, 60, 70, 80, 90, and from here it'll roll back over. It goes to 99 and then it rolls back over to 0. So we'll go 97, 98, 99. And by the way, if you're wondering, this 7.813 kilohertz is just the frequency. But we get 99%, then push it again, and it goes to 0, which 0 always has a little bit on it. I noticed it don't go to completely 0. Then it goes to 1%. So really 1% to 99 is really all you're getting. But I thought it was neat. I thought it'd be handy to have something to do the pulse width that easy. Let's get back out of this. 1, 2, 3. Alright, the next thing on the menu is the C+ ESR at test point 1 and 3. And this is for, we'll go into it, 1, 2, 1, 2, 3. Because what this will do, if you want to test a capacitor without having to hit the button every time, and that's really all this is. If you have a lot of capacitors to check, it'll give you a really quick way of checking them, putting them in, dropping them. So while we're in the capacitor and ESR testing mode, we'll check another electrolytic capacitor on 1 and 3. Automatically shows. I have another 1 and 3, and it's automatic. Series resistance, automatic. So if you have a lot to check, it's pretty handy. One thing to mention, if you do pick up a smaller capacitor that's not really large enough to show ESR, you'll notice it actually won't try to test. So just so you know, it's not a malfunction. It's just it needs to be a large enough capacitor to have ESR checked. All right, getting out of the capacitor test. The next is rotary encoder. Can you see that? The rotary encoder, I don't have exactly what it takes to try to test that, but what I did try to test it with, it doesn't seem to work to me. This is another one of those things, if somebody out there watching, if you have seen or got this to work, or if I missed anything or said anything wrong, please correct. Just put it down in the comments below the video, and that way it'll be a one-stop for anybody wanting to know more information about the 328. But like I say, I have not had success with the rotary encoder. It may be hooked in with the same as the frequency counter part, the functionality. Next we have the self-test, which is something I haven't, since I've had my device. First of all, I hadn't ever had to replace the battery since I've got it. It still does the battery check. You know, when it first comes on, it still shows good. And also, I hadn't had to do a self-test or like calibration. I have seen where people said they would get out of calibration or show a big C when it's checking for the part, or checking part C. But if you have any issues with it or need calibration, go through this. But it tells you when you go into self-test, short the probes, which means 1, 2, and 3. Isolating the probes. Shows the resistance, some type of calculation factor there. Shows okay. This part wants a capacitor across 1 and 3. And it shows that I have version 1.11K. Test ended. And like I say, I hadn't had to do that yet. I tried to go through it for the video demonstration in case anybody had any question about what you need before you get started. But I wouldn't do it unless you have any issues with it, me personally. And then we get to the contrast, which I know a lot of people have had question about. To get into the contrast, you press it down and you see contrast. And mine I have set for 18. Everybody's is a little bit different. I think mine came from the factory at like 24. And it was a little bit darker. I tried to brighten it up for the screen. I hope you can see it okay on the video. But every press you press this, it goes down, indexes by 1. And it will roll over past 0. and back to 64, and which you can't see it because it's so dark, so you have to keep pressing. Alright, start seeing that 25 come down. And once you get the display contrast where you want it, you just hold it down, get back out. The next one is switch off, and it does just that. You hold it down, it switches the unit off. And that's how you get the contrast. That's the number of clicks it takes. And then we roll back over the transistor, and that just takes you back to the normal test mode. And that's everything on the menu. We went over everything. The only other thing I wanted to show you was the current drain on the battery. And to do that, I'm just going to hook my meter up. I have one here set up, my Fluke 87. Get it where you can see the display here. There we go. Showing some DC milliamps. Drawing up the 20 milliamps while testing. Around 13 or so out there's complete with the display on, and you can see once it goes to sleep it goes out of the milliamp scale. So we go to micro, and it's really showing down to the nanoamps. I would say one of the two. I don't have a good way to actually measure that, but it's very low current draw. It should last a long time with the battery. I still just take mine loose. I almost put a switch on it when I was installing the battery here. But it's such a low current drain. If I'm going to put it on the shelf for maybe 6 months, I'll just take the battery loose. If I'm going to use it even once a week, I'll leave mine plugged up. But I just wanted to show the current draw on the device, to show it was as the spec was showing. This concludes our review of the GM328 tester. I hope you learned a little bit from it, and if you got anything to add, just again, please do it in the comments below, and let us know if we missed anything. Let us know if you have more insight of how it works. Please let us know. Post it there so people can see it. In the future, if you have any ideas of reviews you'd like for us to do, just let us know. Also post that below. Give us some ideas of things you would like for us to test. And just to give you some idea, I have over 20 years experience in industrial, electrical, and electronics background. I do have a small business, thrifty tool shed, that does CNC upgrades. CNC equipment as far as burn tables, vertical mills with servo drive and control system upgrades. I have done the small little hobby size CNC and the controls for that. So if it's any ideas for videos or reviews or how-to videos on any of that, let me know. If you got any questions, I'll be glad to try to help and do a video review on them. Thanks a lot for stopping by Thrifty Tool Shed today.